Okay. Hi, everybody. Let's start with a couple of just like housekeeping announcement-y kind of things. So Friday next week is the first day of exams. So, yep. First and second period exams start next Friday, and then the following 3 exam days are Monday, Tuesday, Wednesday the following week. So I'm going to take a few minutes here and talk about our exam format and get you guys some information on that, because I suspect some of us will want to start looking at things as soon as this weekend, so I want to make sure that you guys have stuff. So the exam is 15% of your grade. It's going to cover chapters 1 through 5. 5 is the chapter we're currently working in. The equation sheet in the content library, which you can view here. It goes on and on and on and on and on.
Will we get these on
the equation sheet in the content library will be given to you on your exam. You're going to have 2 to 4 questions per chapter. Your exam format questions will be similar to those found on the review. Each chapter's questions, except things in chapter 1, are worth a similar amount of points. If you turn in the exam review before 2:45 on December 14th, that's the last day of classes. The end of the day on that day, I'll give you 5 points of extra credit on your exam grade, and you can use your review on the exam. Okay, let me repeat that. If you turn your exam review in before the end of the day on the last day of classes, that's December 14th, Thursday, by 2:45, you get 5 points of extra credit on your exam, and you can use the exam review on your exam.
Holy crap. That's if you turn it in.
If you turn it in. Okay? I am not going to publish an answer key for this until 2:45 on Thursday. You're free to ask questions to me about things on there, and I'd be happy to tell you if you did something right or wrong. But I am not going to publish an answer key until everyone that's been eligible to turn it in has turned it in, because it does you no good as preparation for me to tell you the answers and you just write the answers down. I want you to struggle bust your way through remembering how to do these things as part of your review. And because you get to use this on the exam, and it's worth 5 points of extra credit for the exam, I'm hoping that you work pretty hard at that, because it's a pretty nice option to be able to have that for the exam. Am I right? So that's the reasoning there. Now, after 2:45 on Thursday, I will publish a key to the review inside of OneNote. My suggestion to you is when you turn in your exam review, you make a copy of it or take pictures of your answers so that as you're studying, which you'll still want to do, you can check to make sure, ooh, hey, on number 7, I screwed that all up. So you have to make sure that, like, you know that, so you don't use your wrong work from number 7 on the exam. You'll know going into the exam, like, hey, put an X through my number 7. I'm going to write in some correct work. I know what to do because the stuff I studied was the stuff I knew I got wrong from the review. Is everybody okay with that? Makes sense, I hope? Ava.
So we're not checking it in. We're turning it in. You keep it until the final exam?
Correct. Yes.
We can't check our answers?
You can take a picture of it. You can make a copy of it once you've turned it in if you want to keep it to study from. But the thing you're getting back on the exam day is what you turned in to me. Okay? In fact, I encourage you to make a copy or take pictures so that you have your answers to study with. Everybody's okay? As you're doing your exam review, can you write notes to yourself on how to do the problem? As long as it's pertinent to completing that problem, Of course. Like, hey, reference the equation sheet so that you can look at what quadrants sine is cosine or positive or negative in. Or write in your all silly turtles crawl and what that means to yourself. You can put stuff like that inside of the problem as long as it's relevant to doing that problem. So you can make this, I would encourage you to be extra thorough. So if the problem on the exam is a little bit different than the problem on the equation or on the review sheet, you still have some good reference for yourself on how to do the problem generally, not just that specific problem. Does that make sense to you guys? So there's a digital copy here in your OneNote, but I'm going to give you a physical copy right now as well, since I'm asking you to potentially turn this in if you like. But like, come on, who is not going to turn this in?
Yeah, you must be crazy enough.
You would have to be pretty crazy not to. Even if you don't finish, I'll give you prorated out of the 5 points. Whatever you finish, and let you use whatever you finish on the exam. Well, it's 5 chapters worth of stuff.
So I'm just not going there.
They so many things I'm never gonna just figure it out.
Oh.
I got 10 on every lab since then. I get an 8.
Oh, yeah. The LT.
I got a 2 out of 5 on those.
Oh no, what's the removal? Me too. I don't know why.
I think it's because they're only in the project.
Oh really?
We only did the list.
I didn't do anything. I haven't.
I think. Not that much.
I don't know. I thought it was.
My reason
She added the project.
yeah, but that's my reason.
So to be clear, December 14th, I think on the front page it says the 15th. Can you make that update for me? Should be the 14th. I counted wrong when I think I wrote this thing and then didn't catch it till after I printed it. So December 14th, I need a physical copy. You doing this in your OneNote will not count. I need a physical copy of your completed review, or as much as you choose to complete. Okay? So you can use the one I've given you. If you lose that, you can always print another one from your OneNote, right? Because there's a digital version sitting here. Everybody feel good about that? Okay? So the exam format will be similar to the review. The question types will be similar to what you see on the review. You know, I say 2 to 4 questions per chapter. Each chapter will be worth a similar amount of points. That's the gist of it. Feel good? Should make the potential math exam a little less stressful sounding because you get a lot of help, right? All right. Okay. Today we're going to start by taking questions from the homework 1 through 6s. So from chapter 5 that we've been working on, I assigned homework 1 through 6 already, and then we did 7 through 13 in class last time as a group. If you're gone, I would make sure I watch the video from last class while we did 7 through 13 as a class, because I think that'll be quite helpful to you. We did a lot of good work there and talked about a lot of I think we developed a lot of intuition on that day as to how to do these kinds of problems that don't have like one set procedure on how to do it. But we haven't yet taken any questions or talked about the 1 through 6 problems. So I know, Ava, you had a question there. Let's start with you. Do number 1. again, I would reference the review. Okay, reference the review. So it says find sine if cosine is 1/4 and tangent is negative. So what I'm going to begin by doing is trying to decide what else I can tell from tangent being negative. Specifically, I'm going to look for an identity that relates tangent to either sine or cosine or both. If I look at my identity sheet, I see from Q1 that tangent is sine theta over cosine theta, right? And I know that tangent is negative, so I know sine theta over cosine theta is negative. Now I know that cosine is theta's 1/4, right? Which is positive. So if tangent is negative, what can I say about sine theta? So positive divided by positive is negative?
Negative.
Yeah, sine theta has to be negative, right? If tan theta is negative and tan theta is something divided by a positive, the something has to be a negative, right? So I'm going to do that because that tells me about the thing that I'm looking for, right? I want sine theta. Now I'm going to go back and I'm going to look for an identity that relates sine and cosine together. So the identity I notice there that I would use is P1, which says that sine squared plus cosine squared is equal to 1. I know that cosine is 1/4. So I can substitute that in. So I have sine squared theta plus 1/4 squared equals 1. What do I get when I square 1/4? Should be able to do that without a calculator. Not a half. So I square the top and I square the bottom. So it should be 1/16. So far, so good. Now to get sine squared theta by itself, I'm going to subtract 1/16 from both sides. To do that subtraction, what am I going to need to have? Great. What would the common denominator be between 1 and 1/16? 16. So I'm going to write 1 as just 16/16. So that's going to give me sine squared theta equals 15/16. But I don't want sine squared theta. The question asks for just sine theta. What do I need to do to get rid of the squared? So I'll square root both sides. When I square root both sides, what do I need to have? When I square root both sides of an equation. There you go. Very good. And when I square root a fraction, how do I do that? I square root the top, and I square root the bottom. What's the square root of 16? 4. Almost. What do we know about sine theta? It's negative, so do I want the plus or minus? No, I just want the minus. And that's my final answer. Ava, does that feel any better? A little bit. In general, the plan is you use the inequality that's given to you. In this case, the tangent theta, to decide if the thing you're looking for needs to be positive or negative. Once you've determined that, you use a different identity that's going to relate the thing you want to know with the other thing that you do know, and then solve. And you'll use that inequality then to usually decide if it needs to be positive or negative. Okay? That's the typical pattern all the way through. Whether you're doing like 1 and 2, or you're doing 3, 4, 5, and 6, which are the same problems as 1 or 2. You're just using, it's asking you to do more, right? Instead of just asking for one thing, it's asking for all the rest of them. So you'll use more than one identity, but once you figure out the things are positive or negative, it's usually pretty straightforward from there.
So after you figure out if it's positive or negative, then
You'll use another identity to solve for the missing piece, because now you'll know whether it should be positive or negative. Usually a Pythagorean. That doesn't have to be, but usually that's what you end up doing. So far, so good? Okay. We're going to do a little bit from the next type of homework problem, and then I'm going to give you some delta math to work on, and or the rest of the homework set, and then you can take your pick as to kind of what you want to work on for the remainder of the day. Okay, so we'll do like 20 or 30 minutes on the next problem set, just doing some example problems like we did on Monday, and then the last half of class you'll have time to work on one or the other. Nora.
I just want to know, I know you said you had, you're giving us a homework, but like, do you know when that will be?
It's got to be coming pretty soon, right? All right.
Do I have to make it a homework quiz?
We did not done a chapter 5 homework quiz yet.
So do I have to make it happen?
Well, we haven't taken it yet, so there's nothing to make up.
If
Do you have to take it if you miss it?
Yeah.
Well, one homework, I put the drops in already for the semester. So if you don't take it, it'll just end up being the one that's dropped. So that's kind of up to you on what you want to do at that point.
Yeah, that's fine.
Ooh, I might.
Yes, Ellie. I'm sorry. Yeah.
If I do well, if this test I take, if like the chapter 4 test, if this is my best test,
I will obviously update what's going on. Yeah.
Okay.
Just remind me and I'll make sure that I do that. I might forget, so if I do,
all right.
you remind me and I'll happily update it.
All right, thank you.
You're welcome. Yeah. Okay. Let's do this real quick also.
Did not.
Wait, Liz, did you take it already? Oh,
Then I think it really is the same.
like this heat contact that.
Then I have to
That
take,
sounds terrible.
then I have to fit my lit test Monday.
Oh wow.
I'm just gonna tell them I can't take it, so. So I have to suck it up.
All right. So just like before, you guys are going to need to be using your identity sheet. You're going to, I'm going to go around and ask for what to do next. So you and your partner are going to be discussing what to do next.
What thing?
You don't have to do anything together other than like answer when I ask you what to do next.
Very.
Okay. So if you want to move so you're sitting near or next to your person, that would be good. If you need a new identity sheet, they're here on top of the file cabinet.
I think I got one. Yeah.
Should I give my mom this first? Yeah. I just want to ask you, because I don't want to eat some
No, I'm moving.
It's like, I want the one that. Yeah, and doesn't it set it
Mr. Fluid, will I have to make up the ones you guys did last time in class?
You just have to turn in the homework just like everybody else.
So
Oh, so now
are we doing the problems together or is it?
in class though?
It includes the problems we did in class. Yeah, that should be part of a homework. That'll be part of Sunday's homework submission. Yes.
I haven't done math in like 3 weeks, so
No.
this is gonna be a little rough.
Yeah, it's not due till Sunday. So just part of Sunday's homework set. You know what I'm saying?
Ooh, I'm gonna do that. Wait, I might do that too. My mom's birthday's coming up. I need to get her something.
Yeah, there's like a bigger one and then a little one. Where? The dates. What? I don't know. I think one up there. Scroll down. I'll figure it out.
All right. So, this new type of problem, the directions will say, prove the identity. I know. She's okay.
Can I join a group or am I like?
No, you're going solo.
Oh, perfect.
If it was a different student, maybe I'd let you join another group, but you're so good by yourself. You'll be fine.
Yeah.
I know. It's like it's an AVA standard is what it is.
No, you're good.
If you were clueless, I'd feel differently, but you're like, amongst the sharpest. No, you're fine. No, you're going to be good. It'll be good.
Ava's easily the smartest. Grace knows. Grace knows what she's saying.
This was random.
Okay.
This was random. I didn't pick you out of a hat. I just looked at the solo person. I was like, that's fine. All right. So the directions for this type of problem will say prove the identity. I know the P word is scary. Don't panic. It's no different than what we did on Wednesday, except it's easier.
What are we doing Wednesday?
I'm sorry, Monday. Today is Wednesday, right? What is today? Okay, last class. Whatever. I don't know what stinking day it is.
I need help.
So, shh. Okay, so what we're going to be doing, it's just like what we did last time in class, except I think this is easier because you are given the answer. You have the answer.
That whole thing.
No, hold on. Hold on. You guys keep firing questions at me before I could even, like, finish a thought.
Be quiet.
I don't get it.
You asked the same question 4 times.
Okay. So the goal here is going to be taking either the left-hand side or the right-hand side and making it look like the other side. Okay? To do that, the tools we're going to use is algebra and or our identities. So it's doing the same simplification process we did last time, except you're told where you need to stop at. The first thing we need to decide is whether we would like to work on the right-hand side or the left-hand side.
Right.
Typically, and I say typically, you want to pick the more complicated of the two sides. Left-hand side certainly appears to be the more complicated side. Right? The left-hand side has more stuff going on than the right. Everybody agree with that? So the options that we have available to us are going to be algebra things, so like distributing or foiling or factoring or making common denominator, combining like terms, reducing a fraction, things like that, or applying an identity. So changing something, like cosecant, we could change into 1 over sine using like one of our reciprocal identities. Okay? Typically, I think we're better off starting by looking for algebra things before proceeding to identities. But again, that's typically. Doesn't have to be that way every single time. It doesn't have to be that way anytime. You could go in a different order. It's usually just about being, trying to find the most efficient way of doing this. So, Bladen and Layla. Blaine's already decided that the left-hand side should be where we start. I would agree with that.
Yeah.
What do you think we should start by doing? What would be the first thing that we want to do? Do you want to try to do an algebra thing or use an identity? Okay, which identity would you think to use here? So if I'm looking at my identity sheet and we're looking at the left-hand side, I see no sine squareds or cosine squareds or the number 1 anywhere. So P1 should not be a good option because every single one of my trig functions is to the first power, right? I would be, if I'm looking for an identity, I would be looking strictly at the reciprocal and quotient identities because those are the ones that really what I would use if I have stuff to the first power. And I have only stuff to the first power. Right? I have sine to the first, cotangent to the first, cosine to the first, tan to the first. I would be looking only at the reciprocal and quotient identities if I chose to use an identity here. Okay, so if I'm going to use an identity change tangent, which is not a bad idea. I would want to pick an identity or see if I can find an identity that includes a cosine in it, because then maybe things could cancel. Do you have an identity that involves tangent that also has a cosine in it?
Yeah.
What do you see? Yeah, so let's use Q1. And that would allow us to change tangent into sine over cosine. All right. Avery and Nico. Algebra or identity? Okay, what algebra would you like to do here? Again,
Combine the, oh.
I'm lost.
So the algebra things, again, that we can typically do would be like distributing, foiling, factoring, combining like terms, reducing a fraction, making a common denominator. Well, it's their turn right now. You've had your turn.
Is that multiply?
Yes, that is a multiplication dot between those. Yes. Out.
Could we like combine?
We use Q1.
Yeah.
That's what I was thinking.
Turn around.
Did we just like put it?
I'm gonna run out.
I know.
Tangent is sine over cosine. Combine them. Shh. One group should be talking right now. Okay, Avery. You wanted to do something with the two cosines. How are you think you're going to combine them? One is in the numerator and the other's in a denominator. You're on the right track. That's a good place to be looking because there's something to do there algebraically.
Do they like cancel out in some way?
Yeah, so if you think about cosine as a fraction, because there's a multiplication symbol between them, you can certainly do that. Nico, is that what you had in mind?
Yeah, I was getting shouted at by Bladen.
Okay, so we just reduced that fraction. That's what you'd call that action that we just did there. Ellie and Mary, algebra or identity here? Ellie and Mary. Okay.
Algebra.
Okay. What algebra thing would you like to do here?
Distribute.
That's a great idea. If I looked at the right-hand side, there's no multiplication going on over there. So I know at some point I'm going to have to multiply that sign through. Might as well do that now. What do I get when I do sine times sine? Good, sine squared. Colin and Sydney, algebra or identity? I think you're correct. What identity did you have in mind? Well, I wouldn't do anything with the sine squared because I know I'm supposed to have a sine squared in my answer, right? So that part of my answer I think is done. Somehow I need to make this cosine from sine x times cotangent x. So I'd be looking at sine x times cotangent x and trying to do something with that part. Do you see that, everyone?
The quotient?
Well, it's Sydney and Colin's turn, but yes.
Yeah, quotient.
Which quotient identity? Okay. And what are you going to use Q2 to do?
This was called a quotient.
So we're going to change cotangent into cosine over sine. Okay. And now Nora and Delaney. What do we think we should do next? Good. So like reduce that fraction, right? That's what that algebra action you're doing there is called. And if I look now, the two sides are the same. So we're done. Right? Notice that the way that I did this is I just kept, like the right-hand side stays the same. I don't recopy it every time until I get to the very end to show that I did the same thing, but I'm working down my paper rather than left to right. This is the preferred kind of way to demonstrate your work here. But you guys did a great job getting your way through there. Let's look at 54 now. Oh, not 54. 48 now. I'm looking at this is the problems from the problem set, not the review. These kind of problems are on the review. Absolutely, yeah. Do you need someone to go with you? Okay. All right, let's see. Mariana and Reagan. First thing we should decide is whether we'd like to work on the left-hand side or the right-hand side. Why did you pick the right-hand side, Reagan? It looks harder because... Okay, but how many terms are on the right-hand side? 1. How many terms are on the left-hand side? 2. I would probably start with the left-hand side because of that. Even though I see a fraction on the right-hand side, it's just one thing. Typically, it's going to be easier to take two things and turn them into one thing than take one thing and break it apart into two things. Again, I want you guys to, while I'm asking the other people questions, to think about how you would answer this question yourself. This is how we're going to build some intuition on how to do these kinds of problems, because no two are going to really be alike. You're just going to be picking up ways of thinking about the problem from these kinds of discussions that'll help us long term, okay? So let's look at the left-hand side. What would we like to do on that left-hand side? Algebra or identity? I would agree. If we look at tan x plus secant x, there's nothing algebraic we can do, right? There's obviously no distributing or foiling to do. There's nothing to factor. There's no terms to combine. There's no fractions at all. Let's look for some identity or identities. Now, at this point, let me make a suggestion to help make this a little easier for you. Let's look at where we're trying to get to. Our answer that we need to have has sines and cosines in it. So I would probably look for an identity or identities that would allow me to write tangent with just sines and cosines in it, or secant with just sines and cosines in it. And I shouldn't say or, I would say and. I want to do both of those two things. Okay, so R5 is going to allow us to write secant as 1 over cosine. What about the tangent part? Yes. What can I do with tangent? Q1, excellent. Q1 allows us to write tangent as sine over cosine. Very good. Thank you, girls. And here, let's do some highlighting to make it a little bit more clear. So I used Q1 to do this, and we used R5 to do that. So if you're going back to look, that should make life easier. Ellie and Jake. What can we do from here? Algebra or identity? Great. What algebraic thing would you do? Well, it's not a solving problem, so cross multiplication is not something we can do here. Just add them. Why can we do that? Perfect, because we have a common denominator, right? So if I add two fractions with a common denominator, the denominator stays the same. What would the numerator become in this case? So it'd be sine x plus 1, right? I'm going to write as 1 plus sine x. Doesn't really matter, though. Feel okay? Great. Thank you. Next up is Reese and Pauly. What are we thinking here? There is no identity that's going to help you here. This is the trickiest step that you guys have run into. So there's an algebra thing here that we'd want to do. So again, I would recommend to you look at where we're trying to get to. When you say multiply by the inverse, what do you mean there? I see. So what Pauly is saying is what we have right now as a cosine in the bottom, what we're trying to get to as a cosine in the top. Somehow I want to try to flip that fraction. That's a good thought. That's not going to work by flipping that fraction. What I would suggest instead is let's think about what we're missing. Okay? So if I look at the denominator of where we're trying to go, it needs to have a 1 minus sine x in it. The denominator of what we have does not have a 1 minus sine x. Let's just put one in there. Can I do that? As long as I do it to the top and the bottom, I absolutely can do that, right? Does that feel okay? What would I do next? Pauly and Reese, I'm going to still ask you guys since I answered this part mostly for you guys because that's a pretty tricky thing to come up with on your own. Well, if I... Where were you looking at? Yeah, but what operation is going on in between them? Okay, so you have two parentheses with multiplication in between it. It doesn't turn negative. So if you had like something like this, what would you do? Not factor, it's the other F word. FOIL. Let's do the same thing here. Right? I'm going to FOIL this out quickly in my head, since it's just the difference of two squares. You don't want to do that because this part of the numerator or the denominator you want to keep. Remember, that's right. We don't want to touch that. So again, I would like to make a suggestion that all the time, if you're not sure where to go, look at where you have to be going, right? Like what part of your problem is done or looks like it's done. Like here I see, okay, I have that 1 minus sine x in the denominator. I don't want to mess with that anymore because I have what I need in the denominator. Where should you be looking to change? I'd be looking at that part. All right, who's up next? Ava. So I just gave you a hint to be looking at the 1 minus sine x or 1 minus sine squared x as something to do. Correct. We cannot just square root something because we'd have to do that to both sides or we'd have to square it right afterwards. In either one of those cases, we don't have a second side to do it to. And because you don't do things to both sides of the equation. Nope. It's an identity. Mary, what's up? Sure. So let's look at what the numerator looks like. We have 1 minus something squared. What identities have ones and squareds in them? The Pythagorean, specifically P1, is the one that you'd want. We're going to use P1 to rewrite the 1 as sine squared plus cosine squared. And you'd probably be thinking to yourself, now, Mr. Kulik, that seems like it's making things worse because now you have 3 things in the numerator instead of 2 things. Nora? Certainly. Bladen, your partner's gone, so it's going to be on you. What can we do next?
Cancel out the sine squared and sine squared minus sine squared.
Absolutely, that's correct. So we're going to just do an algebra thing, combine some like terms. So those guys cancel out.
Yeah.
So it'd be left with this. Then what can we do?
Take out cosine at the top.
Yeah, we can reduce the fraction. And what are we left with? The answer that we're searching for. So we're done. Just like that. Again, this step here was the trickiest step. Not obvious to do something like that. But in the case where you're stuck, sometimes it just makes the most sense to like, okay, I'm just going to, like multiply by 1 in such a way that I get something that I need where I need it. You know what I'm saying? You could have also multiplied the top and bottom by cosine, although it's a little bit harder, I think, to get to where you want to go. The hint that you'd want to use the 1 minus sine instead of a cosine is because I have this thing, this 1 plus sine x, looks like half of a difference of 2 squares, right? That looks like an a plus b. And the thing that I'm missing looks like the a minus b. Those things go together like peanut butter and jelly. You see an opportunity to do that, that's a good one to take. All right, let's do another. And maybe we just do this the rest of the hours. It seems like this is still a struggle a little bit, and especially for the people that weren't here last class. And that's okay. We can do the delta math on Friday. It's not a big deal, right? 6 of one, half dozen in the other. If you guys feel like we're still being productive here, we can just keep doing this. That's fine. Does that feel like the better option? Okay. Let's just kind of keep doing this. Do you feel like having these kinds of discussions aloud as a group is helpful? Is this a good way of doing this? I'm hoping that it makes a difference rather than just like watching me do it expertly. All right, let's see. We left off on Avery and Nico. Which side should we start this with?
The left. Or the right.
Does it really matter? They kind of equally?
Even if it's the two.
I think they're equal. In general, if I have a fraction like this, I would rather take the fraction that has one thing in the denominator versus the fraction that has two things in the denominator. So I would use the left-hand side here as my tiebreaker, although I don't think that there's a bad choice here. The reason I would do that is if I have one thing in the denominator, I'm able to rewrite a fraction as two fractions with a common denominator. If I have two things in the denominator, I can't do that. But that's my reasoning. So let's use the left-hand side. What would you like to do first with that left-hand side?
Is it an identity?
I would use an identity here, yes. Very good. Which identity would you like to use? Well, the part that appeals... What do you want to use, Avery? Yeah, P3 is the one that I would use, absolutely. Very good. Look at how quick you're catching on. So P3 is going to allow us to rewrite secant squared as tan squared plus 1, and then we still have the minus 1 up there, over sine y. So that's a good choice. Ellie and Mary. What are we going to do next? I love an algebraic idea.
Okay.
What are you thinking to do algebraically? Yeah, look at that numerator. Let's combine some like terms. And again, like, I know it's tempting to ask for help from the peanut gallery. I would strongly encourage you guys to give your own answers. Even if they're wrong, what we're going to do is have a nice discussion about why either that's not a good idea of something to do, or why it's not even okay to do that way, right? And that's really important. Because we want to get rid of all the bad ideas right now before we get to the test, so you're left with only good ideas when it gets to the test time. Paulie, what's up? Certainly. All right. Sydney and Colin. So at this point, let's look at where we're trying to get to again. So we want to get sine y on top and 1 minus sine y squared on the bottom. Right? I would use an identity here. Yes, agreed. There's nothing algebraic to do. Sure. I would be looking at either rewriting sine. Well, let's look at where we're trying to get to, right? Doesn't seem like there's any good way to turn one of those into one of those. But is there a way to get a tan squared to get a sine in it? What did you say? Yeah, I agree. Which quotient? Q1. That's going to turn tangent squared into sine squared over cosine squared, right? And I'm going to write it this way, though. Oops, let's use a different color. Are we okay with how I notated that? Rather than writing as a big complex fraction, I just wrote it as tangent times 1 over sine. And then I replaced tangent squared with sine squared over cosine squared. Let's see, who's next? Nora and Delaney. Any good ideas here? There's no cross multiplying in a non-solving problem. But there is something to do. No, just it'll be on the final. Homework quiz still, sure. What? Yeah. What are you going to simplify? Yeah, you can reduce, right? And again, let's look at where we're trying to get to in this problem. Let's see, whose turn is it? Mariana and Reagan. So we're trying to get here, sine over 1 minus sine squared. And we have sine over cosine squared. Where should we be looking to do something? In the denominators, right? Because the numerators already match. Great idea. Are we going to be looking to do an algebra or an identity? Absolutely. Because there's no other way to change a cosine into a sine, right? Got to have to be an identity. What identities are you going to be looking at? Excellent. Yes. So P1 is the identity you're going to want to use, but we're going to have to use it in a way we haven't used it before. So let's take a look here for a minute. P1 says this, right? I want to use it for cosine. Let me use a different color. So if I subtract sine squared from both sides, we can say that cosine squared is 1 minus sine squared, right?
Can I go to the bathroom?
You guys see that? Does that make sense as to what we did there? So I'm going to do like P1 star. I'm going to put a star next to that because I kind of flipped it around myself. But that's what we need. And everything is the same now. And we're done. Now, if you wanted to add that to your identity sheet in pencil, next to P1 that you can write that cosine squared is 1 minus sine squared, you could do that. And similarly, you can write sine squared is equal to 1 minus cosine squared. You could add those to your identity sheet. Those will come up rather frequently, and you're welcome to use that as an identity, as a version of P1. Look at that. We discovered a new one, and you did it all on your own. I didn't even have to help you. That's a great job. Should have time for at least one more. Let's do another. Let's see, go back and find those problems. Let's see, who's up next? Oh, this is a fun one. Let's see. Ellie and Jake. Which side should we start on? Yeah, for sure, right? Nobody wants to try to turn a 2 into all that nonsense. Okay. What would you like to do first? Algebra or identity? Are you sure? Okay. I would not. You don't have a lot of good identities that are going to change. I mean, all you can do with the cosine or sine is turn them into like 1 over secant or 1 over cosecant. Now you're creating fractions in here, which it seems like a bad idea. Yeah, I think an algebra step here seems like the better option. Specifically, what are we going to do? Not distribute. What does this mean? Definitely not square rooting. You can't square root both sides because you can't do things. Shh. Just let me finish. You can't do something to both sides in a proof. If it was a solving equation, you could do something to both sides, but square roots don't distribute, so square rooting both sides of this because of the plus in between would still be a bad idea. Yes, so thank you, Jake and Ellie. Foiling is what you'd want to do here because the squared means that you really have cosine t minus sine t times cosine t minus sine t plus cosine t plus sine t times cosine t plus sine t. So when we FOIL this out, let's see what we get. There's a lot of stuff. I'm coming back. Reese and Polly.
Oh my gosh. Is this a real problem?
Yeah, homie.
Yeah. Oh, can you stop for a second? Yeah, can you I can't, it's on OneNote. Is it not update on OneNote? Here. No, I have it. Oh my god. I'm sorry. Let's get rid of all of it. I don't like this.
Combining like terms would be a great decision here, Polly. What can we combine together?
Cosine squared, sine squared, cosine, and
Well, this takes up an entire page.
I'm still ready.
That's it.
On your computer.
Whoa. What's that?
That all reduced to just that.
Didn't reduce, we combined like terms. So take a moment and just look at what you have on how we did that. Right? I circled the like terms that we combined. Ava, I think you're next.
Would we use identifier?
Which identity were you thinking?
Sorry.
Shh. Great, which one?
Probably like P1.
Yeah, but before we do that, we should think about factoring the 2 that's in common to both of them. But yeah, that's it. One identity is all we used on that.
When you first died, it was real bright.
I'm getting my head ready for it. I don't even know how we got on this subject.
You're a common target for these girls.
I know.
It's because of all, I think it's all the trash you talk about Taylor Swift.
Yeah.
It makes you a target.
It's horrible.
Makes you a major. My parents were being like Taylor Swift. Keep putting the camera on her. I watch football. I watch football. Yeah.
Are you
The only
serious?
reason I watch football to see Taylor Swift. Watch
That is insane.
actually crazy. Yeah.
Do you think that's crazy?
Me too. I
Why?
watch football now.
You okay? Watching a whole
There was
football
one where she
game
was an
to see her 2 to 3 times.
Mhm. If you like something, you like something. It's fine.
That is weird.
In the most recent game, didn't he?
I don't know. Is it weird to like go watch a 3-hour movie because you like an actor or actress?
No, but like it's different.
But they might only
Better
be
than an entire movie.
not every role is the person on screen the entire movie.
Yeah, but I wouldn't watch it just for an actor.
Okay. Would you watch it for a pretty actress?
No.
That's such a lie.
I'm just saying. I'm just saying. How is it not much different than that, right?
It's different. It's a way different.
You want to make it different, that's fine. It's different to you. I don't think it's much different.
Robbie.
There is no way that is
Who has never seen that movie?
She's already seen Charlie and Jack cheating and that one.
Those are the Oompa Loompas, right?
Yeah, well,
Yeah.
Nora, I'm taking you to see it.
Wait, was that it?
Yeah, we finished. Ava finished it for us.
That's why I'm seeing it.
All right. Bladen, and well, your partner's still ill, so
Oh, we're doing another one?
Yeah. Shh. We're going to do one more because this is a one-step. Shh. This is one step, so we're going to do one more. It doesn't matter which side you start with. They're going to be equally easy. It's the same, ostensibly the same step, because it's one step.
And one person can have to figure it out.
Yep. Bladen's going to do it
Yes.
with maybe a little bit of help from Mr. Kulik.
All right, bro. Relax over there, Mary.
Well, let's call it two steps. Mr. Kulik says it's a one step, but it's probably two for you guys. So it'll be Bladen and whoever's second in command there. Is that Avery and Nico? It's okay. The first step's the hard one.
That's great.
Okay, Bladen, I'm going to give you a hint. It's an algebra step.
Yeah.
Can we get this done, please, and stop talking?
So I want to somehow turn that -1 into a tangent and that +1 into a positive tangent. What can I do algebraically to do that?
-1 to 10.
It's an algebra, not an identity. You don't need your identity sheet.
10 times tan.
Yeah, we'll just multiply the top and bottom by tangent over tangent. That's the tricky step, is to think to do that. Avery and Nico, it's identity time for you. Again, I would caution you to look at where we're trying to go. That part of it looks good. Hi, Alexis. How are you?
Oh, she just spawned out.
Yeah.
Where'd she come from?
Right behind Alex. Shh. So the yellow part looks all set, right? If we look at where we're trying to get to.
Oh, are we looking for identity?
You definitely need an identity here. Absolutely.
That's right.
Is it Q2?
No.
Wait, I lied. Oh no, wait. Is it?
Yeah, it was all negative.
Yeah, could it be R6?
Yeah. So you're going to use R6 to change cotangent into 1 over tangent, correct?
Oh, actually? Oh, she actually did it? I didn't know she actually did it.
Yeah, he doesn't like someone so much that they slash their tire.
They actually slashed?
Yeah.
Who did?
Okay.
It's hilarious.
So we've used R6 twice, right? What's that allow us to do then? Cancel what? We can do that, right? What do I get when I reduce those? Not 0. Yes. So I have 1 over 1, or just 1, and then minus tan V. And then 1 over 1, or just 1, plus tan V. That's exactly what we needed to do. And we're done. Wouldn't it just be 0? No? What is it?
Like, if you want, oh, never
You're
mind.
talking about this?
No, like, the answer.
The answer?
But, like, I get it now.
Okay.
Okay.
All right. So let's stop here.
You didn't stop me.
I never got a text message.
At this point, you guys still have
2 minutes.
52 to 62 still to do. Hey, we did like 6 of those together, right?
Homework was 52 to 60.
Yeah. Next time we'll do some of the delta math and I'll give you some more time in class to work on this stuff. What should you also be doing in the meantime? Study guide. Start working on that study guide. Don't wait till last minute. Okay? It's part of the reason why we're doing all this in class. This chapter 5 homework all in class. Is to make sure we have time for the study guide.